Part 3 of Unit 8 is about different types of solids. We can think of solids as falling into two main groups, and the two main groups are based on how the molecules are arranged within those solids. We have crystalline solids, which are usually ionic compounds. It's a stronger solid that has a repeating three-dimensional pattern of the molecule arrangement. And there's amorphous solids. Amorphous solids, these are more frequently metalloid compounds or some molecular compounds where there's not as much order in arrangement, and it's not always in a 3D framework. It could be just a 2D pattern of bonds. So crystalline solids are a lot stronger because it's a 3D framework and it's a regular repeating pattern. Amorphous solids are not as strong. So an example of an amorphous solid would be glass. On old buildings, the glass in the windows has actually started to sag down. It's getting pulled down by gravity, so the bottom of a sheet of glass would actually be thicker than the top because over time gravity has changed the shape of that amorphous solid. In ionic crystals, the solid structure of ionic bonds, you can think of the arrangement of the ions as layers of close packed spheres. They're going to stack so that there's as many possible attractions to other ionic spheres as possible. So it's not a directly stacking on top of each other. They're offset so that they can be in contact with at least three other ionic spheres, and there are several different patterns of ionic crystals. I'm not going to make you memorize them all. Since ionic crystals all have a repeating 3D pattern, we can focus on the smallest individual unit of it, like this blue square in this picture. That's called a unit cell. We can just focus on the shape of one unit cell in determining the shape of the ionic crystal. Let's talk about covalent network and molecular solids. These two pictures represent the same elements but two very different substances. One on the left, this is a diamond, and on the right, this represents graphite. These are both similar because they've got the exact same chemical formula, C. They're both just made of carbon, but what gives them such different properties is the way the carbon atoms are arranged. In a diamond, it's a 3D framework with each carbon atom being covalently bonded to four other carbon atoms in a very strong repeating pattern. In graphite, the carbon atoms are arranged in sheets. So we've got three separate sheets of carbon atoms shown here, and these layers or sheets are not held together by covalent bonds, but they're held together by van der Waals forces, intermolecular forces. So it's a lot easier to break these sheets apart because they're not actually bonded to each other. There's just some intermolecular attraction. Diamonds are so strong because each carbon atom is bonded in four different directions. And that illustrates the difference between a covalent network, which is a network of covalent bonds, and other molecular solids. Here's a table summarizing different types of solids. It would be good to know the name of the type of solid, the form of the unit particles, what the forces are, and maybe some of the properties. You don't have to know the examples necessarily, but you should know these four parts of the table. Your question for this section: diamond and graphite have the same chemical formula, carbon. Explain why graphite makes a better pencil than diamond.